They must be aware we're after this. They'd gone to Warp 6 also.
Warp factor 7.
Aye, sir.
Something the matter, Mr. Spock?
A sustained Warp 7 speed will be dangerous, Captain.
Thank you, Mr. Spock. I mean to catch them.
We'll either catch them or we'll blow up, Captain. They may be faster than we are.
They'll have to prove it.
What's up, people? Welcome back to Red Barn Garage. Today's video has nothing to do with cars or combustion engines, but if you're anything like me, you'll think this shit is really cool. And to go along with the automotive content, I want my channel to be educational on how all machines work. My day job is I'm an industrial maintenance technician at an automotive production plant. So I work on all the machines in the building: mechanical, electrical, robotics, programmable logic controllers, etc. I pride myself on being able to understand how all the machines and the components in all of the machines work. So I want to educate anyone who wants to know about this stuff. I'm going to call it my How It Works series. Now, I consider myself a pretty smart cat, but I'm nowhere in the same universe as guys like Albert Einstein, Nikola Tesla, Stephen Hawking. Man, that dude couldn't even move nothing but his eyelids and his cheek, and he still managed to figure out how black holes work, amongst many other things. And he managed to get this information out of his head and into the hands of the other scientists and the general public. This dude was legendary. Now, you may have heard of a certain Sir Isaac Newton. You probably remember him as the guy that an apple fell on his head and led to him discovering gravity. Yeah, that was him. But this dude was so smart that he got frustrated because the math that was available to him at the time was not sufficient for him to do the work that he wanted to do. So he just invented calculus. I just wish I could do calculus. A lot of scientists consider him the smartest scientist that ever lived. But anyways, I don't always understand it, but I love learning about science and physics and trying to understand it. I still can't wrap my head around how Schrodinger's cat can be both dead and alive at the same time, but I digress. So you might think that the most powerful things that humans can create are atomic bombs. Well, it's complicated. The bombs that the U.S. dropped on Hiroshima and Nagasaki were fission bombs. They work by splitting atoms. Well, later developments of nuclear weapons produced hydrogen bombs. And these bombs use an atomic bomb as the first stage to ignite the second stage, which is a fusion bomb. Fusion bombs combine hydrogen isotopes to form helium, and this process produces a lot more energy than just splitting atoms. This is the same process that powers the sun. So because we can do it on such a large scale, hydrogen bombs are the most powerful things we can create at the moment. The largest hydrogen bomb ever detonated was built by the Russians. It was called Tsar Bomba. And when it was originally built, they realized that if they detonated it, the plane that was carrying it possibly couldn't get out of the way fast enough, and the crew would be killed. So they cut the power in half. This bomb was still 3,800 times more powerful than the bomb that was dropped on Hiroshima. So this has to be the most powerful thing we can create, right? Depends on how you look at it. So pound for pound, the most powerful form of energy that we know of is created when matter and antimatter meet, and they annihilate each other, releasing even more energy if compared on the same scale as the hydrogen bomb. Antimatter, you say? So you may have heard of antimatter, and you may have thought it was science fiction or just a theory, but antimatter is real, and we can create it. Just we're only capable of making it on a subatomic level. It means the pieces of antimatter that we can make are the same size as the protons, neutrons, and electrons that make up the atom. So we're a long way from being able to make enough of it to use for a bomb, or say for a warp drive engine. We'll get to that. Now, I love science fiction, and most sci-fi nerds are either team Star Wars or team Star Trek. Well, I love both, but Star Trek's better in my opinion. And the reason why is in the name. Star Wars deals mostly with, you guessed it, war. It's all about lightsabers and the pew-pews that never hit anything. But Star Trek's different. It deals a lot more with the science and exploration of space. Yeah, they fight sometimes, but the main component of the plot generally deals with the science. Their mission is to seek out new life and new civilizations, to boldly go where no man has gone before. And a lot of the technology on Star Trek has become reality. Communicators are basically cell phones. The holodeck is virtual reality. We use touchscreens to control everything. We can even 3D print food. Maybe that's kind of similar to the replicators. Not really. And then there's even work being done and progress being made in the field of teleportation, only on a very small scale, like the transporter. Now, things in space are really far apart. Distances are measured in light years, which is the distance traveled by light in a year. And at 671 million miles per hour, light travels a long way very fast. But even if we could travel at the speed of light, it'd still take hundreds and thousands of years to go between stars, much less galaxies or the whole universe. And we can't even get our spaceships anywhere near the speed of light right now. But even if we could, Einstein proved that the speed of light is the universal speed limit. Nothing travels faster than light. But what if there was a way? And this is where Star Trek comes in. In Star Trek, faster than light speed is achieved by warping the fabric of space-time, hence the name warp drive. And the only way they can do that is to make tremendously massive amounts of energy. So theoretically, in Star Trek, they have a magnetic field that contains matter and antimatter. They combine the two when they want to go really fast. This annihilation on such a large scale causes a warping of the fabric of space-time. So the ship basically rides a wave of the space-time to go faster than light. Think of space-time like the fabric on a trampoline. If you put a bowling ball on it, it stretches it. And if you jump on it, it causes waves in the fabric. This is how space-time works. And Einstein proved that space and time are relative to one another, similar to the way that electricity and magnetism are relative. If you run electricity through a wire, it becomes magnetic. And if you run a wire through a magnetic field, it produces electricity in that wire. More on that in a future video. So, by warping the space-time, the Enterprise can essentially break the cosmic speed limit and move it faster than light speed. Now, the warp factors that you see on the show are not like Mach numbers. Mach 9 is 9 times the speed of sound, but warp factor 9 is actually 729 times the speed of light in the show. Just a couple of side notes here for the Star Trek nerds. I'm sure you've heard the crew talk about impulse power. Impulse power is used when the ship needs to move at less than light speed. This impulse power is achieved through fusion reactors, typically fueled by deuterium, which is converted into helium plasma. And you may have heard Scotty or the others talk about dilithium crystals, which Scotty seems to always worry about them cracking when they try to go too fast. But anyways, the dilithium crystals serve to regulate the matter-antimatter reaction, allowing for a controlled release of energy when they're using the warp drive. Now, most of the discoveries in things of a subatomic or smaller than an atom nature have been done in particle accelerators. Now, particle accelerators are machines that use magnetic fields to accelerate particles to nearly the speed of light. And these particles are going in opposite directions around a big circle, and then their paths are crossed, and they're smashed into each other at these astronomical speeds, which breaks them into even smaller particles. The biggest and baddest of these particle accelerators is the Large Hadron Collider, or LHC for short. And this thing is massive, nearly 17-mile long circle in Switzerland. And what it's most famous for is finding the Higgs boson. This is the particle that makes stuff exist. It gives matter mass. But back to the point. So some smarty pants figured out that in these particle accelerators, even a tiny one in a hospital, you can create isotopes of certain types of matter. And isotopes are unstable forms of matter. And when these isotopes decay, they emit positrons. WTF is a positron, you might ask? Well, I'll tell you. In school, we learned that atoms are made up of protons, which have a positive charge, neutrons that have no charge, and electrons that have a negative charge. So, antimatter is just a negative or mirrored state of matter. So a positron is about the same size and has a similar function as an electron, only it has a positive charge. So they put these positron-emitting isotopes into the body in whatever area they are looking for cancer. And soon, the positron is going to bump into an electron. And when it does, the matter and antimatter reaction takes place, and they annihilate each other, and it emits a single burst of light. And this light is picked up by the scanner, and it shows the medical personnel where the cancer is and how big it is. This is called a PET scan, or positron emission tomography. Now, you may be wondering, because we have established that matter-antimatter annihilation gives off the most powerful form of energy that we know of. So why doesn't this blow up the hospital? Well, it's because of the size of the positron and electron that interact. So an atom is really, really small, right? Well, an electron or a positron, they're 10,000 to 100,000 times smaller than a single atom. And that's a number they use just to do calculations. Electrons might not even have any discernible size. So this annihilation is on an extremely small scale. Now, PET scan is not the be-all, end-all solution for cancer diagnosis. PET scans are good for cancer detection, determining the spread or metastasis of cancer, treatment planning, monitoring treatment effectiveness, and detecting reoccurrence. By the way, who do you think created all of these incredible medical technologies that save millions of lives every year? Our communication systems, satellites, GPS. Who do you think invented the atomic bomb that ended World War II? Yeah, it killed a lot of innocent people, and that sucks. But how many more lives did it save? Who do you think gave us the ability to land on the moon and to send robotic rovers to Mars and so much more? I'm barely scratching the surface here. The answer is physicists. Physicists are not only working every day to try and figure out how this universe works on the largest of scales to the smallest of scales and everything in between, but they are also developing new technologies every day to enhance our lives and to keep us safe and healthy. I'd like to thank all the medical professionals out there hard at work to keep our asses above ground and in as good of health as possible. I also would like to thank the scientists like Brian Cox, Brian Greene, especially my man Neil deGrasse Tyson, who is continuing the work of the great Carl Sagan and his widow, Ann Druyan, of bringing science and physics to the masses in a way that we can understand and comprehend it. So, if you want to know more about science and physics, past, present, and future, I highly recommend the original series Cosmos by Carl Sagan and the continuation series of Cosmos created by Ann Druyan and co-created by and hosted by Neil deGrasse Tyson. If you like my content, please like and subscribe. Live long and prosper. Ugh. Hmm. Braves fans, please excuse the hat. I'm a born bred Georgia boy, and I'll be a Braves fan and a Dogs fan till I die. Falcons keep trying me. Like, you're going to run Matt Ryan off for Deshaun Watson? Come on, man. At least it didn't happen. But anyways, I'm an Atlanta Brave till death. But they are hot trash this year. And if they can't win it, I'd rather Mookie Betts, Freddie Freeman, and Shohei Ohtani win it. Mookie's an incredible ball player, Hall of Famer, and a really good dude. On top of that, Freddie is one of the best to ever don a Braves uniform and a first ballot Hall of Famer and an overall just a great human. And then there's Shohei. Not only is he a great person, but this guy has the greatest baseball skill set that the world has ever seen. Sure, Bo Jackson was a better athlete overall, and he could play two sports on an extremely high level. But even he couldn't or didn't pitch at the level Shohei can, all while setting new records for home runs and stolen bases in the same season. Shohei's the truth. Thanks for watching, guys.